Hi, in this video I will explain you what is mean value theorem and how can we use it to show some inequalities. So we have a function f which is continuous on the closed interval ab and differentiable on the open interval ab. Then there is a point c in ab such that f prime of c is equal to fb minus fa over b minus a. So let's see what can we do with this. So, for example, I want to show that sine of x is less or equal than x. This is probably the simplest example we can do. This is, well, we can do it for, this is actually true for all x real numbers, but let's do this only for positive x's, okay? We can do the rest by symmetry. So I'm saying that let's pick a function, okay? I need a function. Let's pick it sine of x. So now I should take derivative of it because in the function I have f prime c. So f prime x is cosine x. So this is saying me that fb minus fa. So here I'm saying by x is greater than 0. What I'm meaning is actually this ab interval is 0x. Okay, so I'm taking any positive x from 0 to x. Okay, so my a is 0 and b is equal to x. So I'm just applying this part. fb minus fa will be fx minus f0, fx minus f0 over x minus 0, which is equal to, so f0 is sine 0, which is 0, so I have just sine x here, and at the bottom part I have x, and so I know that this is gonna be equal to, for some c in the interval of 0x, this should be equal to f prime of c, which is cosine c. And now here where the inequality comes from, I know that cosine c, for any cosine, I know that this is less or equal than 1 for any c. So now I can just finish it by saying, so I'm just multiplying both sides by x, and the inequality is not going to change because x is positive here, it's greater than 0, so sine x is going to be greater, less or equal than x. So this was the first example. And for second one, let's show arctangent of x is less or equal than x. For, again, let's show this for x positive numbers. We can do the rest by, again, symmetry. So I'm again picking it from 0 to x, okay? Again, this is just the same a and b, and I'm picking the function fx being equal to arctangent of x. And derivative of it is going to be 1 over 1 plus x squared. So again, let's write fx. So I will directly write this part. Fx is just arctangent of x. Arctangent of x. And f0, arctangent of 0 is equal to 0 because tangent 0 is 0. So minus 0, I'm not writing that. And at the bottom I have x minus 0, which is x. So this is this part from the problem. And I know that this is going to be equal to f prime of c for some c in this on this interval. So this is going to be equal to 1 over 1 plus c squared. And so c is a real number. And I can basically say that 1 plus c squared is greater than 1 because c squared is positive. Well, I can say greater or equal, but actually c cannot be 0. So 1 over 1 plus c squared is less than 1. So I can say this is again less than 1. And by that, I show that now if I again multiply both sides by x, I have arctangent of x is less than x. Okay, and that's how can I show it. Also a quick note, that in general, like at both of these examples I picked. So I want to show sine, I picked the function being sine, I picked the function being arctangent x. It could be a little different than that, and in general, of course, this is not the general way to show it, so you may need to think up with some other solutions, some other functions.